Yar me painties, shiver me timbers, this be the spiral review for spiral 5. First up, we have to graph some linear equations. Given 2 points, I've got to find the slope, and then write an equation in slope-intercept form. Okay, my 2 points to find the slope from negative 13 to positive 14 is going to be 17. From 2 up to negative 4 is going to be down 6. That's my slope. My equation, I'm going to write in slope-intercept, but first we're going to write it in point-slope. I'll use this guy just for the sake of using this guy. So y plus 13 is equal to negative 17 over 6, and x minus 2. Okay, to put this in slope-intercept form, that's y equals mx plus b. I've got to get the y by itself. Means I'm going to subtract 13 on this side, and I'm also going to have negative 17 over 6. X minus 2 times negative 17 is plus 34 over 6 minus 13. And this stuff I can play with a little bit. That's going to be 17 over 3. And that's negative 39 over 3. Negative 39 over 3 plus 17 over 3 is going to be 22 over 3 negative. So negative 17 over 6x minus 22 over 3 is our answer. Sketch a line using this information. Okay, that looks to me like standard form, which means I'm going to make an xy table and set some zeros for x and y. This is a strategy that's really helpful for you to recognize. If I plug in 0 for x, that means my y is going to be negative 10, because negative 3 times negative 10 is positive 30. So 0, negative 10 is down there. If I plug in 0 for y, I get 5x equals 30, so x equals 6. That means my x-intercept is up there. My line goes through those 2 points, and I've identified both my x and my y-intercept. Moving ever onward, we've got to sketch a graph of the absolute value and piecewise functions labeled below. All right, first things first. I'm actually going to do the absolute value first, just because why not? YOLO, right? First thing I notice with this is I'm looking for whatever makes the inside equal to 0, and that's going to be my middle point. So in this case, that's going to be positive 2. If I plug in positive 2, I'm going to end up getting 0 times a half is 0, plus 1 is 1. So 2, 1 is my vertex. If I go up 1, so to 3, and then to 4, I'm going to end up getting things that are close to this. This is going to be 1.5, and this one would be 2. So 4, 2 is a nice easy point to include. Same with going backwards. If I do 1 and 0, if I plug those points in, I'd get 1.5 and 2. So that's going to be 0, 2. And there is the graph of my absolute value function. I'd like you to notice that that is a v with a vertex at 2, 1, and it has a slope of negative a half. Oh man, I totally did that upside down. So instead of 1.5, this should be 0.5 and 0, and this should be 0.5 and 0. See, kids, what you need to learn from this is don't try to game the system, just plot the points and do the math out, because then we get one that looks like this. And my top graph is totally, well, not totally wrong, but somewhat wrong. So now we have a graph that is a v with a vertex at 2, 1 and a slope of negative 1/2. Now over to the piecewise graph. First things first, I'm going to make my force fields. First one's going to be at 1. And the second one's going to be at positive 4. Okay, I need to graph some points on all 3 pieces of this. So let's say I made an XY table and a couple negative points, maybe negative 2 and negative 3. That'd be fine. And my middle points, that's be between 0 and or 1 and 4. Maybe positive 2 and positive 3. That'd be okay. And then I need a couple points that are really above my second force field, maybe like 5 and 6 or something. Those are both above my second force field. Okay, first one first, I'll do in, let's go green, because I haven't used green yet. I'm using the first equation because we are less than 1 when we're plugging in. Negative 2 plus 4 is going to be 2. So negative 2 comma 2. Okay, and then I plug negative 3 in. Negative 3 plus 4 is going to be not that. Oh, that's negative 1. That's why I was messed up. Negative 3 plus 4 is, in fact, positive 1. So then when I go to draw my line, it hits the force field and pew, stops. And then I go in the opposite direction with the same slope. This is just less than and not less than or equal, so it just gets an open circle. My next line I'm going to do in purple. And that's going to be plugging 2 and 3 in. So if I plug 2 in, now we're using the middle equation because 2 and 3 are between 1 and 4. And for the middle equation, negative 1 times 2 is negative 2. Plus 4 is positive 2, so 2, 2. Besides a dress for ballerinas is also this point. And then if I plug in 3, negative 1 times 3 is going to be negative 3 plus 4 is going to be 1. I draw my line in both directions till I hit the force field. Pew, pew. And because we're less than or equals, you get a closed circle there. And because we're greater than or equals, you get a closed circle there, or less than or equals again, rather. Okay, finally, this one I'm going to do in brown. Oh, no, orange looks fun. And for points that are way to the right, I'm going to use my last equation. If I plug 5 in, 5 minus 4 is going to be 1. So 5 and 1. If I plug 6 in, 6 minus 4 is 2. I draw it until I hit the force field at 4. Pew! And we'd have an open circle here, but it overlaps with a closed circle, so we can just leave it. Here we've got a system of equations, and we're going to solve this using any method of our choice. Given that nothing is particularly easy to get by itself, I'm going to treat this like an elimination problem. And I notice that I can have 4 and 12. If I multiply the top by 3, I get positive 12x minus 3y equals negative 6. So now if I add those equations together, negative 12 plus 12 is 0, 4 plus negative 3 is just y, and 2 plus negative 6 is negative 4. That's it. We're done. Except we have to go back and solve for x now. Okay, I'm going to use the first equation because it looks a little bit easier. So 4x minus, instead of y, I'm going to write negative 4 equals negative 2. So 4x plus 4 equals negative 2. 4x is equal to negative 6, which means x is equal to negative 6 over 4, or negative 3/2. Solve using any method. I have a y by itself, and because I have a y by itself, that suggests substitution would be an expedient solution. So I'm going to replace any y that I see with 2x plus 1. 3x minus 2, 2x plus 1 instead of y, is equal to 5. I'm going to do some distribution. Minus 4x minus 2 equals 5, and there's my 3x. 3x minus 4x is negative 1x minus 2 equals 5. Add 2, I get negative x is equal to positive 7. I've had a whole bunch of students ask me if it's okay if you have this. That all you do is you switch the signs, and that's totally okay. What you're really doing is multiplying both sides by negative 1, and we know from hopefully Algebra 1 that you can multiply both sides of an equation by the same number, and that's totally cool. Going back, I've got y is equal to 2 times negative 7 plus 1. So that means y, I'm going to go up here, sorry, that's my x value. Y is equal to negative 14 plus 1, negative 13. All right, number 7. John and Amanda go to breakfast together. John has a burger and 2 small fries containing 1,000 calories. Nice. I like burgers for breakfast. So that's going to be 1 burger plus 2 small fries equals 1,000 calories. Amanda has 3 burgers and 2 small fries. That equals 2,080 calories. Wow, that's a pretty big breakfast. You know, if you go to Cheesecake Factory for brunch on Sundays, some of their meals, just like they have some kind of a creme brulee French toast that has like 2,500 calories just in that. So you don't even need 3 burgers for that. That's crazy. Okay, back to the math. Now see, I have 2f and 2f. This makes a great problem for substitution. I might try doing some subtraction since those are the same sign. b minus 3b is going to be negative 2b, and 1,000 minus 2080 is going to be negative 1080. Okay, if negative 2b equals negative 1080, I can divide both by negative 2. I get b is equal to 540 calories for a burger. Okay, going back to the beginning, if I have a burger and 2 fries, so 540 plus 2 fries is equal to 1,000. That means that 2 fries is equal to 460 calories, that a fry is going to be 230. I wonder if Mr. Butterworth found this on like the McDonald's website or something, and these are the actual calories for certain items. And for our last section, we have linear inequalities. The first step for any of these is always going to be to draw the line. So if I have x is greater than 3, the first thing I have to do is draw the line x equals 3, which we know is a vertical line. That's going to be through the point x equals 3. Since it's just less than and not less than or equal to, it's going to be a dashed line. If x is greater than 3, I'm going to color in the greater than side of 3. And it would look something like this. Okay, x plus y is equal to 8. That looks like standard form to me. So I'm going to make a table and make 0 for x and for y. I get 8 and 8. So we've got 8, 0 and 0, 8. Graphing through there. Totally hit both points very easily. And what I'm trying to do is figure out which side of this line to color in. If I take a look at a random point, let's say 0, 0, and see what happens. If I plug 0 plus 0, I do get less than 8. That means I'm going to be coloring in this side of the grid. If I had gotten something that was not true, okay, let's say I tried the point, I don't know, 10, 10. We'd get 10 plus 10 is less than 8. Not true. I would not color that side in. I color the opposite side in. A rule of thumb for this is that if we're going less than, with the y on the side, you're going to color the side that is on the bottom. Not a great rule to follow, but it's a good way to kind of check to see if your answers make sense. Okay, number 9. X plus 3y is equal to 4. That looks like standard form to me, so first thing I might do is go x, y, 0, 0. And if 0 is x, y is 4/3. Okay, that's going to be like right there. And if 0 is y, x is going to be 4. Ooh, I just messed that up. 4/3 is there, and 4 is there. This is going to be a solid line. Oh, by the way, this guy over here should totally be a dashed line instead of a solid line because it's less than. So this guy over here is a solid line. Oh, no, it's not. This is a dashed line, too. Wow, I'm on a roll today like butter. And if I take a look at the sides of my graph, if I take the point 0, 0, that's my favorite point to plug in. I get 0 plus 0 is greater than 4. Not true, so I'm going to color in the upper side. Okay, and then for the other one, y is less than or equal to negative 2x plus 6. That's slope-intercept form. So there's my plus 6. Negative 2 means a slope of 2 down. And this one is a solid line because I have less than or equal to. And if y is less than or equal to, we're talking about this bottom side. If I were to plug the point 0, 0 in, we could see that 0 is less than 0 plus 6. Yes, that's true. The last thing I want to mention for both of these two problems is that our solution to these is the area that both pieces overlap. So for this guy, it's where I have purple and green that I now just colored gray. And for this guy, it's this upper triangle that is green and orange that, again, I'm coloring gray.